This is the solution for question 1 on Unit 3 Quiz 1 on complex numbers. This first question asks you to explain a geometric representation of multiplying a complex number by -1 on a complex plane. And write at least one sentence and use examples on the complex plane provided to demonstrate your answer. So this is very similar to the logic that we used in this part of our notes when we were first introduced to graphing complex numbers. So just as a quick review, this part of the notes was really important. Actually, your answer was right in your notes. So here we graphed a couple numbers, and I said specifically, remember back to graphing 2 and multiplying something by -1. And you get -2 from that. When you multiply the number -2 times -1, what does that equal to? That is 2. We plot those 2 points on the number line. This is just real numbers, so real number line. The point 2 and the point -2, they're 180-degree rotations of each other. And we notice that multiplying by -1 has a very specific property, because if we multiply 1 by -1, we get -1. That's also a 180-degree rotation. Take -1 multiplied by -1, we get 1, and that's 180 degrees rotated about the point 0. So we bring that into our latter part of our notes where we're looking at I. Now we're taking I to a higher power. Now we're not multiplying by -1, but we're multiplying it by I. And we observe that every time we multiply by I, we're rotating about the origin by 90 degrees. Multiply by I again, and we rotate by 90 degrees. So using that same logic, let's take a look at question 1 of the quiz. And even if you don't remember that multiplying by -1 is a rotation by 180 degrees, we can make a couple observations using different examples. So I chose a couple different numbers. I chose the complex number I. I is a complex number where the real part is 0. I chose the number 2 because 2 is also a complex number except the imaginary part is 0i. And I chose a complex number 1 plus I. I chose another complex number 2 plus 4i. Both of these have real parts and complex parts. And the reason I chose these 4 examples is because they're all a little bit different. I doesn't have a real part, 2 doesn't have an imaginary part, 1 plus I has both real and both imaginary, and I just wanted to see another example with both real and imaginary. So that's why I chose these 4 numbers. You could have chosen any other numbers. Okay, so taking a look at that, I multiplied each of these by -1, so I times -1 is -I. 2 times -1 is equal to -2. 1 plus I times -1. Don't forget to distribute the negative to both terms, so I get -1 minus I. And the same way, 2 plus 4i times -1, that is -2 times -2 minus 4i. So taking a look at each of these points, I'm going to plot them using the same color because we're comparing what happens to I when we multiply it by -1 to get -I. So take a look at the graph on the right. I plotted I up here because it is 1 unit in the imaginary direction, and -I is 1 unit in the negative I direction. So here's I, here's -I. At this point, you might say to yourself, well, that looks like I and -I are just reflections across the horizontal axis. And that is a great hypothesis. So we're going to keep that in mind. I and -I are reflections across the horizontal axis. But of course, if we make a hypothesis, we have to check with the other examples. So taking a look at my other example, we have 2 and -2. I plotted those in orange. So -2 is here, 2 is here. And double checking my original hypothesis is it a reflection over the x-axis or the real axis? And it is not, because -2 and 2 are not reflections over this horizontal axis. But taking a look, it does reflect over the imaginary axis. So imagine folding this graph in half where this imaginary axis is. That -2 folds on top of the 2. So your hypothesis might be, well, is it a reflection over the x-axis or is it the reflection over the y-axis? It seems like neither of these fit. But if we continue to take a look at the next example, maybe that will help us clarify some things. So I would go ahead and take a look at 1 plus I times -1, that's equal to -1 minus I. I plot those points at 1 plus I, plot the point at -1 minus I, and at this point you'll notice a couple of different things. And that is, there's two solutions for this problem. One is more helpful to you later on, but there's also another solution that is correct, at least when we're looking for geometric representation. So taking a look at 1 plus I and -1 minus I, you might just start to notice that when we were talking about reflections earlier, is if I reflect this point across the x-axis, it should be right here. But then if I take this point right here and then reflect it across the y-axis, I get it to here. So that means if I reflect each of these points across the real axis and then across the imaginary axis again, then it ends up at the point that I want it to land up as. So taking a look at my previous examples, I'm going to change my hypothesis again. And my hypothesis now is I have to reflect it both over the real and the imaginary axis. So if I take this I and I reflect it over the real axis, then I get to -I. And if I take that point at -I and reflect it over imaginary axis, well, it's on the imaginary axis. So it doesn't move, and that is correct. Now if I take the point -2, or I take the point +2 and I reflect it over the real axis is here. If I fold the paper across the real axis, it doesn't move because it's already on that axis. Now if I fold it again across the imaginary axis, that's when it flips over. So it seems like my hypothesis is working. My hypothesis is that it reflects over the real and the imaginary axis. Okay, so taking a look at my fourth example, which is 4 plus I, it actually works out because if I take 2 plus 4I and I reflect it over the x-axis, it should end up at this point down here. And if I reflect it again across the imaginary axis, it ends up being here, which is the point that multiplying by -1 gets me to, -2 minus 4I. So one of the answers would be multiplying by -1 is a reflection across the x-axis and the y-axis. Or when we're talking about rotations, it is a rotation around the origin by 180. What do I mean by that? Much like my example here, I'm going to flip back to the notes. The notes here says that when I multiply something by -1, it rotates it around by 180. It rotates it around by 180. So flipping back here, if I take this -2 and I multiply it by -1, I get to 2, which is rotating around by 180. And multiplying -2 by -1, I also rotate it back to 2. In the same way, I to -I is rotating by 180. -I to I is also rotating by 180. Taking a look at this point, I'm also rotating around about the origin by 180 degrees. If you're not sure what I mean by rotations or reflections, those are transformations that were taught in geometry, so make sure you check in with me if you're not sure what reflection and rotation mean. And if you remember back to geometry, rotating by 180 degrees, either clockwise or counterclockwise, is the same. So that's why I did not mention whether it was clockwise or counterclockwise. But I want to make one more note, and that is when we talked about multiplying by I, it was specifically by counterclockwise by 90 degrees. So don't forget, there's a couple of really key differences here. This is multiplying by I, and here we're multiplying by -1. So it's okay whether you put rotation around the origin by 180 degrees, clockwise or counterclockwise, it's the same. Or I also accepted the answer reflection across the x-axis and y-axis, but make sure you need to say both. Okay, and that is the solution to question number 1 on quiz 1 of unit 3.